What is the mutual gravitational potential energy of the configuration shown in the figure if all the masses are 1 kg? Now suppose initially M1, M2 and M3 are far away at infinity. Work is done to bring M1, then M2 and finally M3 to their respective positions. Now work done to bring M1 to its position is 0 because there's no other bodies around. Work done to bring M2 to its position is given by minus gm1 M2 divided by r, the separation distance between M1 and M2, which is 0.8 meters. Now work done to bring M3 to its position is now minus gm1 M3 over r and minus gm2 M3 over r. So M3 will interact with M1 as well as M2. So the total work done will be minus 3 gmm over r. So at this point, M1, M2 and M3 are all equal mass. So we represent them by m. So substituting values, we get minus 2.5 times 10 to the power of minus 10 joules. What is the work done by an external agent if we were to add in an additional 1 kg mass into the center of the system of masses? Let the new mass be M4 and the distance from the corner to the center of the triangle be D. So D will be equal to 0.4 divided by cosine 30 degrees, so be 0.4619 meters. So this is 0.4 and so this is cosine. Okay, so D cosine 30 is 0.4, so D will be 0.4619. So the work done to bring mass of M4 to the center of the triangle will be minus gm1 M4 divided by r minus gm2 M4 divided by r and minus gm3 M4 divided by r. So substituting values, we'll get minus 4.332 times 10 to the power of minus 10 joules. Explain why this answer is negative. Now gravitational force is attractive. Without the external force, the 1 kg mass will accelerate towards the center of the triangle and gain kinetic energy in the process. The external force therefore acts in the opposite direction such that net force is 0 and the 1 kg mass does not gain kinetic energy. So in order not for it to be accelerating all the way to the center, so the external force has to act in the opposite direction. So the direction of work done by the external force is opposite to the direction of displacement. Hence, the work done by the external force is negative.